After the Rutherford video, you should have written down your observations. You can watch it again if you have to in order to get your observations right. The big deal is that, he expected those alpha particles to go through the gold foil. That was not the surprise. Thomson's theory essentially said that there was a lot of empty space there. It wasn't totally empty. There was like this diffuse positive charge around, but he wasn't that surprised by that. What surprised him were those crazy major deflections. Was said that there was something around that was really small because it wasn't happening very much, but also very dense because it was deflecting those alpha particles almost straight back at times. And again, if you can watch the video again if you want, there are two main conclusions. One, which was not actually all that surprising, is that the atom was made up of mostly empty space. That wasn't too surprising. The surprising part, was that there is a small, dense, and positively charged. And he knew it was positively charged because it repelled the positively charged alpha particles. Small, dense, and positively charged nucleus. He didn't know about protons. He didn't know about neutrons. He understood that there was stuff that was inside the nucleus that was positively charged and that the electrons were outside the nucleus somewhere, but he couldn't tell you where. All that he could tell you is that they were outside the nucleus based on this experiment. A really elegant experiment, though, one that really furthered our understanding of atomic structure using, essentially very early 20th century techniques, and it was really, really very elegant. So those are the main things you need to know of the Rutherford atomic model. He was the first one to really come up with something very close to what you know of as the atom these days, which is the nuclear atomic model. A very brief mention of James Chadwick. Through experiments we're not going to be talking about, he was the discoverer of the neutron. And as you might imagine, that was the hardest one to discover. I'd like you to write down with your partners right now what the reason was that you believe that it would be the hardest one to figure out something about. So I'm going to leave that for you, and we'll talk about it when I get back to the class. So you can press pause and do that with your Smush Pair partner right now. Okay, so you're back, and we only have a little bit left to do, actually. I want to start talking about atoms and what actually makes them up and start counting things. So as you can see, and I'll read for you, which I normally wouldn't do, but since we're on a video, here you go. We've now discussed the properties of the atom, and we're going to talk about the atoms on the periodic table. All atoms of the same element have the same number of protons. I will now tell you all of the exceptions to this rule. None. This number is called the atomic number. So a little bit of definition. Atomic number, number of protons, and it defines the element. So where do you find the atomic number? So I want you to look on your reference table. So take a moment. I'll flip over to this document. You go get your reference tables out and go find the periodic table. And of course, they provide you a key right here, the top middle. You can see the atomic number is the number in bold on the bottom left. That's going to become important a little bit later. But anyway, you can see right here that 1 for hydrogen, that is the atomic number of hydrogen. And so what I want you to do, the answer to this first one is, of course, as 1. And I want you to go to the same spot for these other elements and do that right now. You can press pause. Okay, you're back. I want you to just go through each of them right now all together. It should take you 5 seconds. Nice and out loud. Here we go. I want to hear you, Jenna. Here we go. Are you ready, Joe? Go. Carbon, neon, technetium, iron, tin, lead, silver, gold. Great. Okay. Now, just for your reference, understand that on the test that's on Tuesday, except for technetium, you need to know the names of all those elements without looking at the periodic table. The periodic table at the front of the room will be folded up, so the rest of those you are responsible for. All right, review time. We're going to use this information. How much does a proton weigh? 1 AMU. How much does a neutron weigh? 1 AMU. How much does an electron weigh? Just about 0 AMU, as we said. If you want to get all exact about it, you want to say 1 over 1840 in your notes, go for it. But we're not going to care about that in our calculations. So now here's a question for you. And again, I'll do this when I get back. What would be the formula, mathematical formula, for the mass number, which is the mass of an atom? Look at how much a proton weighs, look at how much a neutron weighs, look at how much an electron weighs, and then decide what you think, how you would calculate the mass of an atom. Okay, and that is all we're going to do today. I will catch up with you guys next week. Thanks so much.